welcome back again to my channel. Like, share, subscribe and follow for more videos. In this video, I wanted us to understand the measurement of time, that's part 2, under measurement of physical quantities. In the last video, we looked at measurement of length using the vernier calipers, meter rule and the micrometer screw gauge. So today we're going to look at the devices or instruments that we can use to measure time, and then we'll go deeper by looking at how we can measure time using those devices. So what we'll start with is a stopwatch and stop clock. Then we'll end this video by talking about the simple pendulum. Now, we know that time is a physical quantity, particularly it is a base quantity. It means it does not need any combination to exist. And so this time is measured in SI units, which are seconds. Please keep in mind that minutes, hours, and other conventions of measuring time are not their SI unit. So if you are taught to state the SI unit of time, you are required to use the second. And each time in physics you are performing calculations, you always convert any given measurement of time back to seconds, because these are the SI units. Otherwise, you'll be finding wrong stuff. Now, let's get deep into looking at the stopwatch and the stop clock and how they can be used to measure time. The stopwatch and the stop clock are used in different events. For example, during a race, it is used in events which require fast recording of time. For example, if you are having a race, you do not need to record an hour, wait for an hour or something like that. You need to look at the seconds that are passing at each and every interval. Apart from that, it can be used in the labs. Labs require very fast and accurate time, of which we can use the stopwatch and the stop clock. The stop clock is usually found on the phone, and it usually just records the number of seconds that are taken. So what we are going to look at particularly here is the stopwatch. Now this stopwatch has got two scales. One is called the minute scale and one is called the second scale. So let us look at how it looks like. So this big scale here that you can see is what we call the second scale. And this is the arrow that will show where the minute or the second is exact. Then this small scale inside is what we call the minute scale. So if you are trying to take readings using this, you must first have or take some precautions. So what precautions must we take? We must make sure that number one, this device is on its 0 point. That is, we must avoid the zero error. Zero error is a situation where your device is not situated at the point 0 or the starting point of that device. And so you must correct that zero error so that you do not make mistakes when you are taking your readings. So the zero error will take place when this device is not at its start point. So for example here, this device here has to start from the point 60 here, which represents 0. And so if you're asked to say, what is the zero error here? They are not saying you must put 0, no. They are asking, what error has it pointed to? Like, what time have you started counting on it? What time have you found on it? What is its zero error initially? So initially, you can see that this is pointing at 10. And this 10 minutes here will be our error because without recording anything, we found this device at 10. So this is an error because it is not at 0. So if you're asked to talk about the zero error or mention the zero error, you just look at the point where it's pointing here. So here it's pointing at 10, and then here it's also pointing at 10. So this is 10 minutes, 10 seconds. I will explain how to read this time in a few minutes. Then yeah, let us look at how we read the term on this. So, firstly, we know that we are looking at minutes and seconds here. So, we must consider first the minutes here and then record the seconds. So, please keep in mind that you must be very careful with how your conversion is. For example, here from 0 to 5, I cannot count 0.1 here, 0.2, 0.3 because I will not reach 5. But if your scale here shows something like 1 here, it means that here your number of seconds will be 0.1, 0.2, up to 0.1. So you must be able to figure out what scale they are using in the question. So in this case, they are using a scale of 1 centimeter. No, let me not use 1 centimeter because there's no length here. They are using a scale of 1. So this is 1, 2, 3, 4, and 5. Now this arrow here, inside here, in the minutes. So the first thing is we'll record it on the minute scale. On the minute scale here, we can see that this arrow is pointing at 10, so this is 10 minutes. Please keep in mind that it does not necessarily always have to be at 10. It can be at 11, 11.5, depending on what scale you are using. Then we'll record on the second scale. On the scale that shows the seconds here, we can see that the arrow is also pointing at 10. So this is 10 seconds. So finally, you just say the time was 10 minutes, 10 seconds. And that is all about the stopwatch and how you can take measurements using it. What really mostly comes, what they'll ask you about, they will examine you about the simple pendulum especially, because it is the one that is used in most cases. So now, let us look at the simple pendulum and how we can use it to measure time. So a simple pendulum is another device that is used to measure time, but this one is measures time very accurately because it measures time in seconds, so to speak. So this device is used mostly when you want to find the acceleration due to gravity, 9.8 grams per centimeter cubed. Yeah, this is 9.8 grams meters per second squared. This is the device that we use to find out what is the acceleration due to gravity when you're performing experiments in the lab. So this simple pendulum, before looking at it, you must look at the terms that are associated with it, because this involves a string tied to a bob and you swinging that bob, right? So yeah, we have the first term, which is called frequency. Frequency, from any other course or subject that you look at, means the number of times something happens, right? So a simple pendulum basically looks something like this. You have a string tied to a bob. So you begin to swing it and then record the time to find the acceleration due to gravity. Yeah. So frequency is how many times this bob swings. How many times the bob swings. Or how many times the bob takes to complete one oscillation. One oscillation means a travel. So let's say this bob starts at this point, and then I pull it, and then I let it go. So if I pull it, it means I'm starting the swinging from this point. If I let it go and then it comes back to the same position where I let it go from, that is called one complete oscillation. So frequency is the number of times taken for a bulb to complete one complete oscillation. So frequency and then number two, we have the same term, which is oscillation. Oscillation simply means swinging of the bulb itself. So when the bulb is swinging from right to left and left to right, that is what we call oscillation. The swinging of the bulb from one position to the other. Number three, there we have period. Period means time. So period is the time taken for this bulb to complete one oscillation. Frequency is the number, how many times it swings. But period is the time taken. Period means time. A period of what? Of time. So period is the time taken for a bulb to make a complete oscillation, right? Now, looking at these terms, let us get familiar with some formulas that we must consider if we are looking at this simple pendulum. So I want you to keep one formula in mind, which is the formula for period. Period is symbolized by the capital letter T. Period is equal to the time taken over the number of oscillations. So how many times it makes a complete oscillation will be this number of what? Of oscillations. Then the time taken, you'll be given the question, sometimes you'll not be given, but asked to find the time, then you'll be given the period, or vice versa. Then we also have the formula for frequency. Frequency is equal to 1 over period. This is formula 1. That will help us significantly to find the what? The frequency. If you don't want to calculate frequency using this formula, you can say frequency is equal to number of oscillations over time. So we can see here that period is the opposite of what? Of frequency. Now, using these formulas, you can be able to tackle any question related to simple pendulum. Now, let us go into the examples. So this question says, the following diagram shows a simple pendulum that swings from A to B to C and back to B in 2 minutes. So, ladies and gentlemen, I want you to keep one thing in mind. The distance between 2 points in a pendulum always gives a 0.25. So this is a 0.25, and also this is a 0.25, which gives us a 1 when we add them together. or we can say this is Imompanga Jongo, sure. Sure, man. So when we have a diagram like this, we can see that the distance between 2 points of this pendulum is a 1/4. This is also 1/4. So you must understand that whenever a pendulum moves from one point to another, it will always have a distance of 1/4. But if you have the whole lot of this length, it will be a 1/2. So this is something that you will not be given in the question, but you have to know it, because this will give you the number of oscillations you require if in the question you have not been given this number of oscillations. Yes. So now, we are taught to say this swinged from A to B to C and back to B. So we have how many 1/4s? We have 3. If it swings from A to B to C, back to B, and back to A, we would have another 1/4. If it only swings from A to B, we would have had 1/4. But if you didn't have this here and then it swings from A to C, then you would have what? 1/2, because the whole lot of the oscillation is a 1/2. So I want you to get this point. So having been given this, the first question is saying find the period. Number 2 is saying finding the frequency. And then the last one is saying stating one factor that affects and one factor that does not affect period of pendulum. So let us answer this question together. So we'll start with the period. I gave you a formula. If you can recall, pause this video and try to calculate. Yeah. So we said period is equal to what? All right, let me erase this part since we've already read the question. I'll only leave the diagram. So say period is equal to the time taken over number of oscillations. Remember in the question, the time taken was 2 minutes. Now remember that minutes are not the SI units for time, and so we must convert them to what? To seconds. How do we do it? So if you want, you can use dimension analysis, of which I'll teach you after this simple pendulum. But what I'll just say is, if 1 minute is equal to 60 seconds, what of 2 minutes? That is equal to x. So x will be equal to 120 seconds. So our period is equal to time taken, 120, over number of oscillations. Now, number of oscillations were 3 here, and so you add them up. You make this to be a point. So say 1/4, this will be what? 4 into 1 is 0 point. 4 into 10, that's 2, remainder 2. 4 into 20, that's a 5. Yes. So you have 0.25. So this is a 0.25, a 0.25, 0.25. So you add this 0.25. So 0.25 plus 0.25 plus 0.25, you have 0.75. So you divide this by 0.75, and then what you get, I do not have a calculator at the moment, but when you divide, that would be your final answer. And then for frequency, we'll say frequency is equal to number of oscillations over time taken. So here the number of oscillations was down, we'll put it up over 120 seconds. If you divide, you also get your frequency. Finally, we have state one factor that affects the period of pendulum and one factor that does not affect the period of pendulum. So one factor that affects the period of pendulum and one factor that does not affect. So the factor that does not affect is the mass of the bulb. So the mass of the bulb here does not affect this period of the pendulum, but the length does affect the period of pendulum. So having learned that, we are done with this simple pendulum, but I just wanted to add on a little part that will help you with conversion of units. All right. So we'll end this video by talking about conversion of units. So I'll just do two examples. One, we'll have to convert 100 kilometers per hour to meters per second. Then number two, we'll have to convert 365 years into seconds. So that's like converting a year into seconds. So I know that this sometimes becomes really hard, but it's one of the easiest things you can do. So let's begin with the first part. So we have 100 kilometers per hour. It means it's over an hour. Now, if you are trying to convert this using what we call dimension analysis, you have to put what you are converting on the opposite side. Remember, we learned in mathematics that if you have h over h, this will cancel and then you will remain with 1. So your goal here is to put what you have down here on the opposite side and what you have down up there down here. Now we know that when you are converting hours to seconds, we cannot convert it directly. You first have to convert it to what? To minutes. And then you convert it to what? To seconds. So we know that 1 hour is equal to what? 60 minutes. Now looking at this, we can see that the hour is there and the 60 minutes is there. So we'll say multiplied by, we'll put the hour on top. Why? Because we want to cancel it. And then we'll put the 60 minutes down there. So we've converted it into minutes. Then we'll convert it into seconds by saying 1 minute is equal to what? 60 seconds. What over this number of minutes. So if we want to convert this now to seconds, we'll put the minutes there on top, since this will cancel, and then you have your 60 seconds there. So on the seconds part, you have been able to convert. Then you now go to the what? To the kilometer part, converting it to meters. So we know that 1 kilometer is equal to 1,000 meters. And so what we'll do, we'll put the kilometers on the opposite side. So say times 1 kilometer down so that it kills this kilometer. You can't put it up. And then 1,000 will be on top there. So you cancel this, cancel this, cancel this. And we can see that the units that we are remaining with is meters per second. So all you have to do is get your calculator, punch this that is on top, and divide by the multiplication of what is down, and you've converted your units. So that you can use the same principle to convert 365 years into what? Into seconds. So I want you to drop the answer of this into the comment section, and thank you. See you in the next video.